So, welcome back to our calculus. In our first lecture, we at the end of that lecture we concluded that rate of change of a relation can be constant or it can change depends upon the relation. It depends on the relation. There are relations say like y is equal to say 2x, y is equal to 2x, where rate of change is constant, and there are relations like y is equal to x square where rate of change is not constant. In all linear relations rate of change is constant, but in non-linear relations rate of change is variable. Non-linear means, as you know, when variable, one of the variables has a power other than 1. Now why do we say that rate of change is constant here? Because we saw in that last video lecture, we saw that if we in order to calculate rate of change, what do we need? We need two changes, delta y by delta x. Two changes we need. Now the size of these changes does not matter. If you calculate rate of change of this, the size does not matter. You can take any size of any size of delta x. You can take any size of delta x. Now, but in this case, size of this matters. Delta y by delta x size of delta x matters. We saw it. If we take one size, if we take delta x equal to one size, if we give it one size, then we get one rate of change. If you change the size of delta x, we get a different rate of change. That becomes confusing, because then rate of change loses its meaning for such relations. This confusion can be solved. See what is the confusion? Confusion is that you don't have one rate of change, you have many rates of changes. And then when you ask me what is the rate of change of this, I don't have one single answer. That is the confusion. We can resolve this confusion if we add a phrase, a few words. If we append a few words to rate of change, say we have been speaking of rate of change of y with respect to x, okay, but we will now add a few more words to it. We will qualify it with rate of change of y with respect to w, or t means with respect to x at a point. This is the phrase that I wanted to append with this. At a point, if you now say what is rate of change at a point, every confusion is resolved. How? In order to understand that, you will have to, instead of going to these expressions, algebraic expressions, we will have to go to graphs of these. So if you want to graph this, you need a few points, few values of x and y. You have x equal to, say, you can start with this x and y here. X equal to 0, y equal to 2 into 0, that is 0. X equal to 1, y is equal to 2 into 1, that is 2. X equal to 2, y is equal to 2 to the 4, and so on. And for our this topic, now y is equal to x square. In case of y is equal to x square, you have x, y. Now x0, y0, x1, y1 squared. 1 squared is 1. x2, y 2 squared. 2 squared is 2. There is one interesting thing in case of this equation. Instead of 1, you could have substituted minus 1 here, and to your surprise, you will get, if you substitute minus 1 here instead of 1, it will be minus 1 square. Now minus 1 square means multiplying minus 1 twice. Minus 1, that is minus plus, that it will give you plus 1. So this will give you plus 1, again plus 1. And if you substitute minus 2, you will get minus 2 square, that is plus 4. And there is a mistake here. When I substituted x equal to 2 here, y should have been 2 square, that is 4, not 2, 4. It is 4. Now, these are points enough for us to plot their graphs of, first of all, here is the let's plot them on the same graph. we have this as our suppose this is our graph paper, and here we have x, here we have y. Now this is 0, this is 1, 1 2 3 4 5. Okay, similarly you have 1 2 1 2 3 4 4 sorry 4 5 5 6 7 8 9. Okay, and similarly we have here a few negative points, -1 -2 2, and for us we first plot y is equal to 2x, y is equal to 2x. So for y is equal to 2x, you had that you have these tables. The table will be table. I will draw a table here. Table here is x. This is y. You have 0 0 0 0 1 2 1 2 2 4 2 4. Okay. Now with these things, you have 0 0. That is the first point. You have 1 2 1 and 2. This is the second point. You have 2 and 4 2 and 4. That these 3 points are enough. We can we can join them, we will get a straight line. This is a straight line. Okay. Now interesting thing about this straight line is that if you change change x anywhere, and then record the corresponding change in y, we will find that the corresponding change in y will be exactly same provided change in x is same. To be say, let us, instead of talking, let us do it. When you go from this to this, how much does x change? X is 0 here, x is 1 here. So when you go from this to this, x change by 1 unit. Let's calculate corresponding change in y. Corresponding change in y is, there is y 0, here y is 0, and there y is 2. So corresponding change in y is this is change in x, this is change in y, this much change in y, this is change in x. Okay. Now suppose so how much is corresponding change in y? We can write it down. Change in x is 1, change in x equal to 1 here. Change in corresponding change in y is equal to, look how much does y change. Initially it was 0, now it is 2, y is 2. So 2 minus 0, that is 2, change in y is 2. If we calculate rate of change of this line, straight line, at this point here in this region, it will come out to be rate of change, as you know, that's delta y by delta x. That will be delta y by delta x. That will be 2 by 1. That's 2. If instead of calculating rate of change here, suppose I wanted to calculate the rate of change here, so I will take this, I will change x here by 1 unit from 3 to 4. Let me see how much does y change. First of all, you have this situation. When x is equal to 3, how much is y? You can straight away go to the graph and then explore what y is. You can see y is 6, y is x3, y is 6, x4, y, you can see yourself, y is 8, x4, y 8. You have this y8, x4, y8. So this 8. Now at the beginning y is 6, at the end of this interval y is 8. So how much change do you bring about in y? That is delta y changed by 2. So when you change x here by 1, delta x equal to 1, y changes by 2. What does that mean? Again, rate of change is same. So rate of change of this graph is same here. In fact, it's everywhere same. In fact, there is a physical meaning, a geometrical meaning of this rate of change. Now what that is? Suppose you have some line like this. If a line is horizontal, we say it has no slope. But if it is a little bit inclined like this, we say it has slope. If it is more inclined, we say it has more slope. If it is little more inclined, we say it has more slope. So what you can easily develop the notion of the slope. Steepness. Slope means steepness. So the steeper a line is, the more its slope is. Okay, but how do you measure this steepness? Yes, we can measure this steepness here. You have suppose this is x and this y, and you have a line like this, one line like this, another line you have, again you have x and y, and another line you have like this, 1 and 2, 1 and 2. Which of the two is more steep? Definitely 2. 2 is more steep. Imagine as if this is a mountain, a hill. This is a hill and this too is a hill. It will be more difficult to climb this hill than to climb this hill. So we say that it has more slope, it has less slope. But see, suppose I drop a perpendicular from the end, from the tip of this line, and also from the tip of this line. You can see immediately that the length of the perpendicular is more here, less here. It is better to actually the contrast is not so much. Let us do it again in order to avoid any confusion. Suppose I take a line like this with less slope, then I take a line like this with more slope of equal length, of course. Length of this and length of this should be equal. So now suppose you drop a perpendicular from its tip on this axis. Do same thing here. What do you find? Length of perpendicular more here, less here. This perpendicular is called rise of the straight line. It tells you by what amount the straight line is rising. Rise in the straight line, and this piece is called run of the straight line. It tells you how much you have to run and then to rise to reach here. And you can see slope as you know by its meaning. Slope is denoted by m, and this slope is directly proportional to the rise. That means where the rise is more, slope is more. Rise here is less, slope is less. So we can write it rise by run. Rise by run. Where run is more, slope is less. Run. You know, these two are inversely proportional. Run more, slope less. You can keep this thing with you until you absorb this idea that this is less slope because it has more run. One has to run more and then rise a little. Here one has to run less but rise a lot. This is more slope. Okay, now this slope, incidentally, this slope is the same as rate of change. Slope is the same as what you call delta y by delta x is basically geometrically it is the slope. Geometrically it is the slope. How do I know it is slope? Well, I will tell you. Suppose you calculated rate of change from this. How did you calculate it? You divided delta y by delta x. Delta y by delta x. But what is delta y? That's rise. Delta y is rise. The perpendicular rise. It is rise. What about delta x? It is run. This is run. So you have rise by run. Rise by run. Rise by run is delta y by delta x means rise by run. But what is that rise by run? Slope. So when you are calculating rate of change, you are in fact finding slope of the line. If slope of the line is more, it means rate of change is more. If slope of the line is less, it means rate of change is less. An example will show you this. That is, for example, instead of y is equal to 2x, had I plotted y is equal to 3x, I would get this graph. Y is equal to 3x. I would get this first x, y, x0, y0, x1, y3, x2, y3 to the 6. Let's plot this much. Now 0, 0, 0, 0 is this. then 1 3, 1 and 2, not 2, 1 and 3, 1 and 3, then 2 and 6, 2 and 6, 2 and 6. You have a line now like this second line, line 1, line 2. If I ask you which of the two has more slope, you will definitely tell me, sir, this has more slope. This definitely, because it's steeper compared to this. Now I ask you, which of the two has more rate of change? That is to be found. As far as this straight line is concerned, we have already found that rate of change is 2 by 1, that is 2. Now what about this? For that, what we do, we let x change by a unit. In case of this, in case of line number 2, let x change by a unit. For example, any wire, it will not matter, because the relation is linear. So rate of change will be same everywhere. Suppose I change x from 2 to 3. Say this is the change in x from 2 to 3. Initially x was 2, finally x is 3. Okay, what is change in x? That is 3 minus 2, that is 1. I will keep it separate from this. Then now I do one thing. I take x equal to 3. X equal to 3 I have already taken. I'm sorry. I will see what is the value of y when x equal to 2. When x equal to 2, what is the value of y? X equal to 2, y is equal to, let me see what y is equal to. In case of this second line, y is equal to, you can see 6, exactly 6. Y is equal to 6. When x equal to 2, you can see that, check it from here. X equal to 2, y is equal to 6. Okay. When x equal to 3, what is y? Let me find what is y. It is x equal to 3. You can yourself see x equal to 3, y is equal to, it is 9. It will be 9 here. For this, it is 9. You can calculate that even from here if you have a doubt. 3 3s are 9. So x equal to 3, y is equal to 9. What is then corresponding change in y? Yes, corresponding change in y. 9 minus 6, that is 3. What is rate of change in this case? Delta y by delta x. That is, delta y by delta x is 3 by 1. 3 by 1. What was rate of change, dear? 2 by 1. What is rate of change here? 3 by 1. Which of the two has more rate of change? This has more rate of change. Which has more rate of change? This, which has more slope. This means rate of change is the slope. Is this slope? Now, if I ask you, suppose, for example, suppose I ask you, what is the compare the slope of these two lines, 1 and 2. 1 2. Which has more slope? 2. Which will have more rate of change? You will say 2, sir. Definitely. 2 changes more. In 2, y changes more with x than what it changes in first. So rate of change is slope. Rate of change is another meaning, it is slope. Okay, now the problem with those relations which are non-linear is this. Let's take now the non-linear relation y is equal to x square, and I had already prepared some table for it. Anyhow, let us do this again here. X y, x0, put x equal to 0, y 0 square, that is 0, x1, y 1 square, that is 1, x minus 1, y 1, because minus 1 square is 1, and then x equal to 2, y is equal to x equal to 2, y is equal to 2 square, that is 4, x is equal to minus 2. Now minus 2 square, that is 4. If I have these pointers, these are enough. You have x, you have y here. Okay, now x equal to 1, it is x equal to 1, x equal to 2, x equal to 3, and so on. Here I have minus 1, minus 2, minus 3, and so on. And y is 1, 2, 3, 4, 5, 6, etc. Now x0, y0, that is the first point. x0, y0. x1, y1, x1, y1. Second point. X minus 1, y1, y1. xc, x minus 1, y1, x minus 1, y1. x2 y4, x2 y4 is this is 24, x minus 2 y4. Plot these. Yes. You have the graph. This is called parabola, and we'll be using this after 1 or 2 days in machine learning. We'll be using this in gradient descent algorithm. This will be very important for us. So please have one more look at this. You have got this graph from this equation, y is equal to x squared. So the graph here is not a straight line. It's a bowl-shaped graph. We call it bowl-shaped this graph. Now, this graph is not a straight line. Now, graph is not straight line, has some consequences. What are those? You can check it here. Suppose you have a graph like this, and a graph like this, and a graph like this. Sorry for this. Graph like this. Suppose I tell you to do one thing. What actually I want you to do. Suppose I tell you that cut a few pieces from this curve and cut a few pieces from this curve and draw those pieces. Draw those pieces beside the line or the curve on one of its sides without changing the orientation, their orientation. What does it mean, not changing orientation? So, see, suppose you have something like this. In which direction is it pointing? It is pointing in this direction. Now, if I tell you that bring this here, but do not change its direction, then you will have to draw it like this. Bring this here and keep this direction same. If this was west, this is west, for example. Now, we say this is called translation. This is called translation. You have not changed the orientation. On the other hand, if you had done this, you have done something like this. Now, looking at this and looking at this, you can easily check that they do not have same direction. The directions are different. Okay, now what this has to do with all this, you can see yourself. Suppose you cut a piece of this, cut a piece of this here, cut a piece of this here, or cut a piece of this anywhere, say here, and then suppose you cut a piece of this, and then draw this piece here besides this without changing its orientation. Don't change its orientation. Then if you change orientation, all this effort will go useless. Now here again draw this, again draw this. Okay, I now ask you, I tell you, my dear, tell me one thing. Is the steepness of this and these three pieces, steepness of these three pieces, same or different? Maybe you won't be able to decide, but then I will take you first to this and then ask you to decide now. That is, suppose you cut a piece here, and then draw it. The piece should be small so that no curvature should come within the piece. It is to be a straight line. Now this piece is this. Then cut a piece here and draw it. This is the piece. This is the piece here. And cut a piece here. Suppose, for example, this graph goes up and cut a piece here. This is a piece here and draw it here. What do you find? Look at this. Suppose I produce this. I produce this on this side. This. And I produce this. Now tell me, have these three pieces same steepness? No. A person, suppose it is a hill, this is a mountain. A person will, as he climbs up and up, he will find that the mountain becomes more difficult to navigate. More and more difficult, because the steepness is increasing. The slope of this curve changes from point to point. So we have this once again. Suppose once again a more clear vision of this. Suppose you have a curve like this. This is a curve, and then I ask you, cut a piece here. You cut a piece here and draw it parallel to this piece. Then cut a piece here, draw it parallel to this piece. Now look at this and look at this. You will easily recognize that this has lesser slope, lesser steepness. This has much higher steepness, and this has even higher than this. It is almost vertical. Okay. So what we conclude from this very important thing, very important thing, that is slope of a straight line at every point is constant. Slope of a straight line at cut a piece of a straight line at any point, it will have same steepness. You can produce it. It will coincide with that. That means this mountain and that mountain have the same steepness. Same is the case with this, but here you have seen yourself what happens. So we conclude and end this this video lecture with one more thing, that is slope of a straight line is constant, but slope of a curved line is not constant. It changes from place to place. But what does slope mean? Slope means rate of change. Slope means rate of change. One meaning of slope is rate of change. What the if you translate the slope into rate of change, then you will say rate of change of a linear relation remains constant. Rate of change of a non-linear relation changes from point to point. From point to point. At one point, rate of change is one value. At another point, it is another value, and so on. So on. That is why I added this phrase, rate of change at a point, because it varies from point to point. I hope you understand this. Now is the last phase. How to calculate rate of change at a point. That will be in next short video. Thank you.